cannot speak.
Your voice is not okay.
Hello, everyone. Please mute yourself if you're not speaking.
Try it in German.
Right. Hello, everyone. My name is Lorenz Bauer, and I'm a technology broker in Hungary, and I would like to welcome you all to the finals of the technology transfer competition. We have to help burst of new ideas into life in the space sector, to use these potentials in the already existing space IPs and products, find new potentials for them here on Earth. And in this competition, there was very fierce competition within the applicants, and we received very, very good applications. So because of this, because of the quality of the applicants, it's very, very hard to select those who will represent themselves here in the final round. But here we are, we have our finalists, and you will see their pitches soon. Here you will see our agenda for today. So first of all, this is the welcoming part, which will be followed by a presentation of the top 5 applicants. After the presentation, the jury is going to retrieve and decide who is going to be the winner of the grand prize of 10,000 euros and who is going to receive the second and third prize as well. During this time, I will hear 2 short presentations from myself about the business incubation and broker programs. The second one is going to be about the Spark Funding initiative, represented by Minus Plus and platform companies, represented by Geza Chira, and one of the participants of the programs who will receive some information from first hand. After this, we are going to present the results. But before we get into a deep dive into the presentation, I would like to introduce to you our jury. Bartol Kigalszky leads the first Space Law and Policy Institute in Hungary as head of the department at the Hungarian University of Public Service. Second, Don Kalausis, managing director. Don is an executive level ICT. He's an executive level ICT consultant with over 20 years of professional experience in communication, like consultancy, interim management, and business law. Last but not least, Kristóf Molnár, deputy at Design Terminal. Kristóf is an experienced team leader with a strong background in marketing and communication. Throughout his career, he had the chance to manage teams of various sizes and multiple segments of without further ado, we're going to head to the presentation part itself, where each participant is going to have 3 minutes to present his idea, which will be followed from the jury. First, I would like to ask to share his screen presentation, Peter Bartos from GeoSentinel. Peter, the floor is yours.
Thank you. Let's share my presentation. Okay, can you see it and can you hear me well?
Yes, thank you.
Okay, wonderful.
Starts now.
Okay, good afternoon, everyone. I'm Peter Farkas from GeoSentinel, and in this short presentation, you get to know how our technology transfer idea works, and also you will learn how sausages are related to indoor navigation. So, who likes to wait, or who likes to miss their flight or be late from their meeting? Or as a service provider, who likes to have unhappy customers or lose money? I think no one. And the underlying problem is the indoor navigation is hard to solve because the GNSS corrections are difficult to obtain indoors without the using of external devices or external services. And of course, the installation of the specific hardware that helps you navigate indoors is costly and difficult. Our proposed solution, called Fast Indoor Navigation and Direction, in short FIND, is solving this problem in a smart way. So we have converting the lost time of the users to efficiently spend time, for example, for shopping. So using FIND, we use only the smartphones of the users to receive accurate position indoors. So without our corrections, the position indoors could be as wrong as 100 meters from your actual location, but we can improve this by a magnitude of 2 to only 1 meter. So using this accurate position indoors, customers could find what they are looking for. For example, the gate where their flight will leave, or the shops, or their parking location. And of course, service providers could increase revenues by reducing this wasted time and increase the satisfaction of their customers. So we use not one, but two ESA IPs. The first one is a machine learning algorithm that improves the positioning accuracy by improving the PVT solution. The second one is a time synchronization method that basically uses the data from the different devices to synchronize their time and give better positioning and time synchronization in indoor difficult conditions. So it's time for that sausage now. For a nice sausage, you need some raw meat, some spices, and some work, maybe some palinka, and then you receive a nice sausage. It is even better if you include this in a nice English breakfast. Our method works in a similar fashion. First, we receive the raw GNSS data from the customer, and we use the ESA technology and put some work in to calculate the accurate indoor position. And then,
yes.
Sorry?
I'm sorry, the 3 minutes is over. Please.
Okay, just
finish your last sentence. Yes, exactly.
Okay, so the user can include this in the application, and just here this is the last slide. So that's what I'm not will talk about.
Any questions from the jury to Peter? Yes, Don, please.
Yeah, thank you. Just a quick question, Peter. So can I understand how you manage to ensure continuity of the resolved position, especially the timing between when you get acquisition to the satellite, when you're in line of sight with the constellation, and then when the client device is indoors? I understand you're using a combination of patents of the ML and AI, but how do you retain the time synchronization in the device, and what is the drift on that over a period of time?
Thanks for the question. So one of the patent helps this by synchronizing the time between the devices. So even if one of the devices is not directly getting any observation from the satellite, then we can still get a continuous positioning stream for them. That's the idea. And that patent works in a way that even if you only have satellite signals in multiple situations, then you can still get an accurate time synchronization.
Thank you. Krzysztof, please raise your question.
Hi, thank you for the presentation. I have a question about the business model. I know that you didn't have time to elaborate on this. If I understand correctly, this thing works like Waze, right? So everyone downloads it to navigate inside a shopping mall, and then the preciseness of the device or of the application comes from the fact that everyone has it on their phone. Do I understand that correctly?
Okay, so just what is included in this site. So we plan this as a B2B business, that we are not creating an application, but we provide an API for the user. So, for example, at a shopping mall, the mall already has an application with a map included, and our service could be included in their application. So
Okay.
they don't need to, the user don't need to download our application because we don't have any, but all business customers of ours can include this service in their application to get better positioning indoors.
Okay, thank you.
Thank you. I think this was all our time for the question round. Peter, please stop sharing your screen, and I would like to ask Gabor Gatesy to take the floor.
Thank you.
Thank you, Peter. Gabor, your 3 minutes starts now.
Statistically, more than 60% of you, dear audience, use the Global Navigation Satellite System, or GNSS, already today, which is one of the most widely used space-related services on Earth. We cannot even imagine our life without the global positioning, which became a critical infrastructure of humanity. But the usage of GNSS is limited by its precision, locking and tracking speed, weather and atmospheric conditions, poor reception among tall buildings or other obstacles, and sensitivity for data corruption. Yes, we all know these issues, right? How many times have you driven your car and went further in the wrong line or direction due to poor accuracy or signal reception? These weaknesses of the GNSS are known for a while, even the possibility for data corruption. In a James Bond movie from 1997, the corrupted positioning signals almost caused World War III. Can you imagine the social impact if someone starts to create false signals for self-driving cars or UAVs? The innovative idea is to apply not one, but 3 ESA-patented methods combination on the data processing to eliminate the mentioned problems. Firstly, we apply AI accelerations and corrections for improved precision, the second IP for improved tracking and enhanced environmental disturbance tolerance, and the third one for security to ensure that the output data is valid and not corrupted. This solution can revolutionize global positioning for everyone. Can you imagine how much fuel we could save globally in transportation with this? You will never turn the wrong way with your car for GNSS reasons. Less accidents, more harvested food in agriculture, more security in the upcoming and future applications like self-driving cars, delivery drones, and others, not to mention defense applications, which became more and more important these days. We are sure that this solution is feasible, but for further research activity and more details about the ESA patents needs necessary to decide if it could work as easily as a software upgrade or a new app in your phone, or a new hardware development is needed. So we hope that you liked our idea for a better positioning in the future. And this was my really short presentation about the AI SGS idea for this competition. Thank you very much for the opportunity.
Thank you, Gabor, for this very good presentation. I'll give the floor to Krzysztof to raise his question.
Hi, Gabor. Thanks very much for the presentation. I have a rather simple question. Why do you think no one has ever done this? I mean, considering Waze being acquired by Google, having all the money in the world, if this is possible, why do you think that they didn't do this yet?
Mm-hmm. Well, I don't know when did these patents came out, but one of the reasons could be about the AI topic is the hardware-based acceleration. So I think that the opportunities for this, the technical opportunities for these kind of solutions are just opened in a last few years. And to be honest, I don't know if you have seen the movie about the Google Maps. These giant these giants like Google are a little bit slow in these kind of development ways. For example, the people who invented the origins of the Google Maps, it all happened more than 10 years before the Google Maps actually came into the picture. So I think that the main reason is this basically. One of the reasons could be the availability of the ISA patent, and one reason could be technical.
Okay, thank you.
You're welcome.
We have time for one more question if the jury would like to address Gabor. Yes, Dan.
Yes, thanks, Gabor. The way you prevent the scintillation effects in the ionosphere, so is that purely on a statistical model, and how valid is that based on the varying thickness of the ionosphere, both temporally as well as geographically around the world? Is the model that sophisticated that it can cope for those variabilities?
Well, only the second IP, the second ISA patent aims to like solve this kind of problems or help with the sensitivity of environmental conditions. And actually, if I understood correctly about the public description of the IP, they used different the combination of different tracking methods in the patent to improve. So the result would be to a less sensitive system. And the ionospheric effects, it's not just about weathering conditions, but it could be also about solar activity as well, for example. So it's kind of complex topic, I think. I don't know if
we have reached the end of our time with the Q&A. So thank you for the answers, Gabor, and the presentation.
Maybe that, okay, I just...
Thank you, and now I would like to give the floor to Marcel Kovács and Bence Kertész to give their presentation.
Good afternoon. Can you see our presentation?
Yes. Your 3 minutes will start now.
Imagine a world that the Arctic's frozen waters become a thriving trade route, unlocking unprecedented opportunities for commerce and exploration. At TRICE, we are turning this vision into reality. Global trade faces clear challenges. Fuel prices are huge, and shipping is slow on non-Arctic routes, while navigating the Arctic is risky due to unpredictable ice movements. To combat this challenge, ground technology is not capable enough, and previous efforts were primary scientific projects with limited capacity. We are thrilled to introduce a game-changing solution using the Paris patent in ground applications for the first time. Paris is a breakthrough in passive altimetry, allowing us to track ice movements precisely and cost-effectively, enabling forecasting. Our vision goes beyond understanding the Arctic. It's about revolutionizing navigation. Our service maps, calculates, and secures efficient and safe routes for large-scale Arctic shipping. We are the ones who can convert the Paris patent into a benefit for this planet for the very first time. The economic benefits are remarkable. Using our service on Arctic shipping routes, companies can reduce shipping time by 40%, cut costs by 40%, and boost annual capacity by 40%, gaining a strong competitive advantage. Each trip with our technology saves $800,000. It means more efficiency, precision, and safety. This technology opens the door to mass Arctic shipping, potentially transforming global trade positively. Picture this: up to 200,000 trips each year, every one of them with a huge opportunity. Our client companies could save up to $800,000 per trip, a real game changer. With these impressive numbers, the return on investment takes less than 14 months. This is more than an innovation, it's an economic revolution in the making. Beyond our project's economic benefits, TRICE marks a turning point for the environment. Our solution reduces CO2 emissions by an outstanding 40% per trip. To put this in perspective, just 1 year's use of our technology on a single route could save emissions equal to Ljubljana's annual carbon footprint. Thank you for your time and attention. Together we can transform Arctic shipping, delivering both economic benefits and environmental change.
Thank you, Marcel. Any question to Marcel? All right. Yes, Dan, please go ahead.
Thanks, Marcel. Those are impressive figures, and forgive me for challenging them. There's a lot of 40% there. So could I challenge or could you clarify the provenance of those figures? How were they derived? Are these your calculations, or were they independently produced, and under what basis?
Of course, they also brought you there some.
We brought backup slides to prove our calculations, and we rounded them down. Everything which is 40% is rounded down, not up. Here you can see how many days you need to like ship across the traditional route and the Arctic route, and how much it saves. It's around 42%. We rounded it down to 40%. And we also have a business plan. You can see how like we calculated that on a route with that time and fuel used, a company on a route could like save up to $800,000. So we made a sale price of an $80,000 price per trip. And we also have a figure on the environmental study. We calculated the fuel saved per trip, how much CO2 it saved per trip, how much carbon it saved per trip, and how much carbon is saved per route. And we defined the route based on the Beijing, New York route, which has 15 ships going at the same time at every moment, and it goes all year round.
Thank you, Marcel. Christoph, please go ahead. You're still muted.
Sorry. So thanks for the great presentation. Did I understand correctly that you mentioned that it was going to cost 80,000 per trip, the solution?
For companies, yes, because they could save up to like $800,000 per trip, because it would cut their fuel costs by 40%, which is the biggest factor in international shipping, and these ships are enormous.
Mm-hmm. So in terms of percentages, how much does that 80,000, how big of a percentage of their total cost is that? So how much does an average trip cost?
An average trip is around $2-3 million in fuel.
Okay, thank you.
Thank you, Marcel, for the great presentation. And next, I would like to ask to the podium Daniel Lipovic to share and introduce his idea.
Yeah.
Daniel, yours 3 minutes starts now.
I was just a week away from finishing my laboratory project with a scanning tunneling microscope. My supervisor came to my desk, leaned over and looked at my results, and thereby ruined 4 weeks of work. I wished I could buy back that time, sacrifice the replaceable for the irreplaceable. What happened? Scanning tunneling microscope, a sensitive device, is vital in many fields of research, from quantum technologies to the material sciences. They enable atomic level imaging by scanning the surface with a sharp needle. The tip is barely a few atoms wide. These are obviously fragile. At the slightest force, a person touching the desk might break them. One of these tips cost up to 500 euros, and due to human errors and natural degradation, they usually last barely for a few hours. Position stabilization is not an unknown problem, and it is present in the space sector as well. Many satellites, such as the Hubble Space Telescope, has to rely on a so-called reaction wheel system to be pointed at a very small object in the sky. A reaction wheel system is 3 wheels mounted along the 3 axes of the satellite. Using the conservation of angular momentum, a precise attitude control can be achieved by slowing down or speeding up these wheels. If the wheels were mounted on a mechanical bearing system, their own vibrations would transmit into the satellite, defeating their own very purpose. That is where the European Space Agency patent gas bearing system comes in. It does exactly that. It avoids physical contact. It mounts the wheels using pressurized gas. Our proposal builds on these gas bearings. Attaching a downscaled version of a reaction wheel system to the needle of an STM will provide protection against human errors and other uncontrollable sources of vibrations. They prolong the lifespan of a needle. By studying the needle, they also improve the resolution of the device. During the development process, we realized that just by doubling the average lifespan of a needle, we would save up to 1,000 euros per device per day. This would double the potential number of STMs in the possession of any laboratory. This would cut waiting times and make precision measurements available for small and medium companies as well. Furthermore, this would open up educational possibilities as well, because you could give it out to students as well. With your support, we will reach out to major industry players such as Bruker and NanoSurf to carry out a feasibility study and then move on to creating a prototype for testing. Quantum technology and material sciences are a great concern today, so having access to STMs will provide an edge there. That is how we are going to use the replaceable to save the irreplaceable time of researchers and entrepreneurs. Thank you very much for your attention. What questions do you have for me?
Thank you, Daniel. Any questions from the jury? Who would like to go first? Balázs, please.
Do you have any concurrent service provider on the market with who you should make competition?
So there are 2 technologies for stabilization of scanning tunneling microscopes. Both are different to ours. One is a completely passive stabilization system, and this is an airbed basically on which you can place your STM, and hopefully it will damp out vibrations. But this is a passive stabilization system. Ours has an edge because it would be an active stabilization system, in the sense that by speeding and decelerating the wheels, it is an active stabilization. And the other method is an active stabilization system. It relies on piezoelectric crystals, but you should know that this is the same system that the LIGO gravitational wave detectors use, and it is incredibly costly. It has been developed only a few years ago, and this is only available to the most high-end research institutions in the world. So yes, these 2 competing technologies exist, but ours combine their benefits in a sense, because ours would be both a passive and an active stabilizations, as the wheels provide just that. They can, if they are just spinning, that's already a passive stabilization, but they are able to provide an active one as well. Does it answer your question?
Thank you, yes.
We have time for one more question, if you'd like. That we can move ahead. Thank you, Daniel, for the interesting presentation.
Thank you very much.
And I would like to ask the floor Ákos Radványi to introduce their idea.
Good afternoon.
Good afternoon.
Can you see my screen?
Yes, and your 3 minutes will start now.
So what if I told you that we can prevent the spread of forest fires on time? Wildfires nowadays pose a global problem, showing no mercy. They threaten homes, families, communities, but countless animals are also in danger. To fight with this global problem, our idea is to develop a high-altitude, long-endurance, or HAIL platform for detecting and managing forest fires on time with the provided imaging spectrometers. As researchers from Stucky, our team has been assembled in a way to find a solution to all the possible challenges that we can encounter, like imagery or active control, electronics, or even mechanical aspects. The two biggest competitive technologies are UAVs and satellites. However, based on this radar diagram, you can clearly see why our technology is preferable in terms of emergency management. For example, unlike regular satellites, or the HAIL platforms can continuously cover large areas that are exposed to fire, and they can stay in the stratosphere for months thanks to the applied solar panels. The spectral information can be used to improve firefighting management, and this can be done by monitoring the soil and the plant moisture. And this way we can predict the possible directions of fire propagation. Our uniqueness is in affordability and in the specialized design against forest fires, which gives us an edge over HAIL platform market competitors like Airbus Zephyr or the Hawk 30 model of HAPSMobile. To further illustrate the potential of our technology, imagine that using only 4 of these platforms could sufficiently shield the majority of Greece against possible forest fires. But similarly, 7 or maybe 8 devices would be enough to cover the state of California. To concern some financial aspects, the table shows some well-known fire events, and below the table we also indicated the estimated cost of a HAIL platform with camera. Selling it as a service, government agencies, insurance companies, or farmers from the agriculture might be interested as stakeholders. Choosing this technology, millions or even billions of dollars can be saved each year, which in turn can be spent on forestation or on improving the water management systems. The choice is in our hands. Let's ensure together that forest fires are just a memory of the past, and we step on a path towards forest recovery instead. Thank you.
Thank you, Ákos, for this presentation. An exciting idea. Any questions for this solution, regarding this solution from the jury? Yes, Dan, please go ahead.
Yes, thank you, Ákos. So HAILs are not new. They're well established in military and other Earth observation applications. I understand you've got some advanced imagery technology here, but could you just emphasize why this satisfies the novelty criteria?
Yes, so we are unique in the sense that we want to specialize this design for forest fires. So we want to enhance mobility. We don't want to use advanced communication technologies or wireless broadband connectivity. So we will use only that hardware that is necessary for that purpose. And for example, we will limit our operation time for the dry season, where the forest fires are more likely to happen, and that way we can achieve even greater speeds than the HAIL platforms now. So that way we can be more effective in case of an emergency situation. I don't know if it answers your questions.
Yeah, thank you. The only consideration perhaps would be to have a multi-mission HAIL so that it could also support emergency communications for firefighters, but no, that's fine. Thank you.
Thank you. Any more questions? All right, thank you very much, Ákos, for the answers and presentation. Now, while the jury is going to retreat to make their decision regarding the first 3 placement of this competition, I'm going to introduce to you a couple of our initiatives in connection from ESA, which helps the commercialization here down Earth. One second. I'm so sorry. One. Got some technical difficulties. I'm so sorry. So we have two distinguished products during the commercialization phase here. Hungary, all operated by Design Terminal. And this the first one is the, one second. Yes, I'm sorry. I'm on the right track. Sorry for technical difficulties. It was on my end. So here at Design Terminal, we are responsible for two separate ways of commercialization initiatives, all through ESA. The first one is the Business Incubation Centers, and the second one is the Technology Broker and Spark Funding Program. This is a joint initiatives, and in the next couple of minutes, I'm going to introduce both of them to you. Each has its separate goal and separate audience to fill. First one, I would like to talk to you about the BIC as the Business Incubation Centers program. This program is approximately 1 year and 2 year long program. And here we're looking for those startups or young companies within the space sector who would like to develop a new space product or service and are looking for help to do so. They are at the right place at the BIC program, because this is exactly an incubation initiative made for them. During the program length, we help these companies to mature their product, their business, and give them relevant help in doing so. Here you can see the separate aspects of this program. First of all, we are giving them business mentoring, like one-to-one mentoring, idea validation, workshops on merchandising, business development, marketing, and presentation techniques. We also give them technology assistance in through meeting with technology partners who are experts in the space field, namely already mature space companies, or we'll also give them technical opportunities to further develop their product and make it a better market fit. We'll also give legal assistance to these companies on one aspect on how to manage the business from a legal perspective. We also give them help in IP related questions and how to manage IP in this sense. For these companies, the office space is also something which they many times lack, and because of this, we see this as an invaluable help that we here at Design Terminal can provide them with shared workspace, which they can use for their own meetings or work from. We also provide a one-lifetime opportunity for these companies throughout our events, which we also make our own events, such as Space Cafe, or recently the one which was the annual meeting of the ESA technology brokers and BIC managers, where we invited a lot of alumni and other big companies to join us and meet with ESA staff and relevant companies from the European marketplace. And also we enlist them in opportunities and events all across Europe, where they have the opportunity to meet with fellow space enthusiast companies and expand their network and find new business opportunities. And of course, last but not least, the participants of the program receives €50,000 non-repayable grant, which is of course subject to milestone which they need to achieve, but still this is a huge amount of money which they can spend on developing their business and their product. This program really is an excellent opportunity for those companies who would like to start a company within the space sector and lack this management or technology skills to do so. This is the place where they need to be applied to. Our second program is the ESA Technology Broker program. This has a bit different focus. Here you can see the help which we can give through this program. Within Technology Broker, we're looking for more mature companies who already have an existing space product, which could be transferred to another realm with here down on Earth. So brokers' work is to help these companies find an alternative use of their product, such as which we aim with this very competition where we were using ESA patents and softwares to transfer to another realm and another sector. This is something similar but way bigger. We are here not just to help raise and find out an idea, but to help throughout the program connect these companies with relevant partners here down on Earth and follow through the whole process, giving them mentoring on technology scouting or brokering introductions with other companies, and also business support and coaching when they are dealing with this joint project together with the companies here down on Earth. We also, to support this whole program, there is the Spark Funding initiative, which is kind of a program within the program. And this whole, the whole idea of Spark Funding is to help this technology transfer of bringing down space products to Earth to find them an alternative use. So these companies who apply to Spark Funding will have 6 to 12 months to achieve and build technology transfer and build the space product into their services and product. And to do this, they will receive a 60,000 euro non-refundable grant to help achieve this this program, this goal. So all in all, in this program, we are helping creating new market segments, creating new program to merging the space product with something here down on Earth. But this will be introduced to you more in depth after my presentation. So all in all, our goal through these programs is to help strengthen the Hungarian space ecosystem, because by the joint forces of this program, we can create a strong, we can create new companies, help new companies enter the market, and strengthen the already existing companies who have valid and strong products. Throughout our network, we can help these participants to get university collaboration, find new technological partners, bring them to networking event, finding new partners, new business opportunities. And of course, we also here to help them in dealing with ESA, the European Space Agency's other programs and other initiatives to get more funding for their projects. All in all, these are our programs, these are our projects. And I think they are really, really useful in the sense of helping the Hungarian space ecosystem and space companies. Thank you for your attention. And with this, I would like to give the floor to one of the representative of our company, two companies, Minus Plus and Mafform. They jointly applied for Spark Funding and already in the program with their project. And here we have Géza Csire, managing partners from Mafform, who are going to introduce to you their experience with Spark Funding and will tell you about how this program works from a company's perspective. Géza, the floor is yours. Please unmute yourself, sorry.
Yeah, maybe it's better if you hear me. Yeah, so thanks for the introduction. And a little bit about both of our companies. Mafform is an innovation agency. We work on high added value projects. We do really complex engineering solutions and patents. And it means one of the fields which is connected to our projects is the compliant mechanisms. So it's basically machines that bend. They not necessarily have the traditional joints or structures, but have made components that capable of bending, and that gives them an advantage over traditional mechanisms. And Minus Plus is a architecture studio, and they create really livable spaces. And they observed that the parasols and the sunshades on the streets are rather ugly and inefficient. So they approached us whether we can do, they had a vision how to make it really nice. And when they approached that, so we already had a technical solution, which was using these compliant elements. And we thought that we should combine these two, and we started to develop a parasol. But the main idea there was not just the compliant aspect, but how to collapse the parasol into a really small space and open it into a really wide space. And that's why we started to look into space patterns. And I will share my screen and a minute. Sorry, it tells me I have to quit and reopen my Zoom to do this. I will do that. One moment, please.
While we are waiting for Geza, just one quick extra information about Spark funding. It's the thing that you usually need two companies, one from space aspect, which I told who's the technology provider is giving the technology, and one from the Earth application who has a product and would like to implement the space product within their product. So usually these programs are a joint cooperation or collaboration, but you also can use such as Geza and IP from ESA's database and ESA's software and IP database. So the Spark funding is open also for those ideas which you just described now. And Geza's back.
I'm back. Yeah, sorry. It also started to update itself just at the right time. So we started to look into space. It was before the Spark funding, and this is my screen. Yeah, and here I hope you can see this. This is a solar
sail. Yes, we can see it. Thank you.
Okay. So this is a solar sail, and you can see it's like a very compact thing and opens up into a really large area. And this was really nice. It looks like if we can do it on Earth, this would give us a really nice parasol. So yeah, we did that. We started to look into solar sails and deorbiting sails, which basically do with really minimal materials. They open up a really large surface. And what we observed was that these usually use a segmented approach, and like these cross rods in them, which is also webbed, and that's not really good in a Earth application. But as you can see here, when it's folded, can you see my mouse? I'm basically using it as a pointer. So one of the edges are never really bent. And so the main idea was that elongate that edge until we get a really nicely webbed shape, which can open and close. And yeah, this is also a version of these things. This is an American. The previous two was developed in cooperation with ESA, with other companies. And this is an American version. And based on these ideas, we started to develop our own version, which has like only 4 segments, and it wraps the textile on its rod. So we did a proof of concept version of this. And one of the interesting things, it works really easily. It's just a simple move. And this is just a proof of concept, obviously, that it can wrap itself, and it also does this semi-automatically. The geometry itself, when there is about 60 kilometers of wind, which is like a large wind that already takes some of the roofing of buildings. So that's a storm that closes this mechanism in the same way as you can see here. Also, we did an experiment with the tooling. So even like in a lot of cases, hostesses and young people, teenagers are the ones who are opening these shades, and they might not be tall enough or strong enough to open it. So we did a tool for this. But yeah, this is the basic system, and this is based on a space mechanism. The main patent we had a patent on it, and the main patent it references is a space patent. And that's why when we heard about the Technology Broker program and the Spark funding, we thought that this is something which is being supported here, that we have taken a space technology, the solar sail folding structure, and brought it back to Earth to create a parasol which consists of less materials than the umbrella type parasols, and it is a really simple mechanism. It only basically 4 joints, 2 rods, and 2 springs inside them, and a really clever geometric configuration. And so less materials than a umbrella type, and without any electricity or sensors. It's half automatic. It closes automatically. And we showcased this to this Spark funding, and they chose to support this project, because as you can see right now, this is a proof of concept prototype. It is only able to demonstrate that the mechanism itself works. We also left it outside for a month in winds, and checked on it for a lot of time, and so to see whether it can withstand weather at all. And we were just really looking for an opportunity to propel this from a proof of concept stage. So it's like a technology readiness level of 4 or 5 up to technology readiness level 8 or 9, which is the levels of just before putting it onto the market. So the stage where we know the final materials and the final technologies that will produce the product, and but we not necessarily have like a proper customer base for it, but we already have interested customers. So that is what we started to do this year, and in less than a year, I don't know, it's like 10 months from now, we hope to have a proper market-ready prototype. And we are really glad that ESA started to support the project. And I don't know if you have any questions.
At the moment, really thank you very much and appreciate that you came and introduced your product and how Spark funding could help to realize your project. And unfortunately, we are a bit behind schedule. This is why at this time we won't have time for questions. I'm so sorry, okay. But if anyone has questions, just feel free to reach out to me, and I will be happy to connect you with Geza in the future. Thank you for the presentation and all the useful information.
Yes, so I recommend the program, and I have to leave now, but thanks for for the opportunity for this presentation.
Thank you for joining us, Geza.
And somehow I can stop this share, right? Yeah. Okay. Thanks. Goodbye. Hello.
Thank you. Goodbye. And now, without further ado, I would like to give the floor to the jury and Don to present their evaluation and declare the winners.
Thank you, Lawrence. Well, I think I should begin by congratulating everybody for their submissions. I think these are very tough competitions to judge because the quality of the submissions are so high, and it always is troubling when you have to do a series of elimination, which the judges did manage to achieve, and unanimously so. I think that when you consider that 60% of the score came from novelty and feasibility, it helped us narrow down the winners, but it was a close competition for all of you. So take that on board, please. Now, it gives me great pleasure to announce the winners. And to begin with, may I start with the third place finalist and winner, which is Trice with the Arctic shipping routes. So congratulations, guys. Well done.
Thank you very much.
Silent applause there in the background. Great. So the second prize. We are very happy to announce that DM Limited with their gas bearing system has been selected for second prize. So again, congratulations, guys. Well done. And I guess first place, which everyone is waiting for. And again, a really tough choice, but I think it was well deserved. And we would like to give special congratulations to Find and their indoor navigation solution. Again, well done, guys. And I look forward to being able to navigate around a supermarket and perhaps a car park without getting lost, thanks to your innovation. Well done.
Thank you very much.
Congratulations. Thank you very much, Don. Really a huge round of applause for all the participants, and I'm congratulated for the winners as well. We'll be reaching out to you this week with the further details about the prizes and the contracts. But this concludes our event for today. Really, thank you for joining us. And please keep up the good work. And don't forget that Spark Funding is also open for these kind of ideas, which you just presented today, which we're going to open at next week for the 2024 selection. So that's going to be another opportunity for you where you can get into an ESA program. Really, congratulations to all, and thank you for joining us. Have a good night.
Thank
Goodbye.
you very much. Goodbye.
Good night.
Thank you very much. Goodbye.